Nigel, Simon, thanks for joining. Very much appreciate you coming along. I suppose in the first instance, it would be good to hear a little bit about yourselves and your company. Nigel, you've spoken before, very familiar to the Meshwork audience, but Simon, perhaps you could start by introducing yourself and tell us what you've been up to at Heatio. I know you've busy raising money from a seed fund perspective, so I know it's all go for you guys.
It is, yeah. No, it's it's great to be here. Thank you very much. So yes, Simon Roberts. I'm the co-founder for Heatio. We are developing a virtual power plant. My particular background is from a heating engineering perspective. So I started off doing my apprenticeship on as a heat pump installer about 18 years ago now. So I've been in heat pumps my whole life, and the kind of concept for Heatio was born out of the fact that we were doing a lot of design and specification work for residential retrofit heat pump installations, where we were getting applications denied by the DNO due to concerns over overloading the network with the heat pumps, battery storage, EV chargers being connected. And we were told if we could come up with a way that could ensure that we didn't overload the network, that they would grant the application. So we started looking into that and realized actually the way to do that would be to balance the network in the home and ensure that we didn't put undue pressure on the grid. And then as things kind of developed, we realized that actually to do that, you need a very well-structured system architecture and platform to do that. And that kind of snowballed into the virtual power plant, but certainly born out of a love for heat pump systems. And as you mentioned, we're currently in our seed funding round. We've just returned from Helsinki at a big investor tech conference out there. We're working with E.ON on a project to see a large scale rollout of renewable energy systems into residential properties using energy as a service as the product, which is a unique funding mechanism where we remove the capital cost of the installation and instead the consumer pays a monthly service fee to have the technology installed on the home with the Heatio home energy management system and virtual power plant embedded within that. So that's triggered our funding raise. So we're cracking on with that at the moment.
Cool. So just a naive question then. I mean, who's your customer then? Who pays you?
The homeowner.
The homeowner, right?
Yeah, certainly for the foreseeable future, we do hope that at some point this will become a kind of embedded solution, not too dissimilar to kind of smart meters in the home, where it could be added on or embedded into the energy bill, and you essentially collect it through your energy supplier, and it's a transferable asset in that way. So that's the long-term ambition, but certainly for the short term, it would be the consumer.
Cool. Cheers, Simon. And Nigel, last time we had you on, you weren't working for Octopus, so things move fast, and you enjoying your time there?
Yeah, good afternoon, everyone. So yeah, Nigel Banks, I'm Technical Director at Octopus Energy in our Zero Bills team. I'll explain about what we're doing in Zero Bills perhaps later on, but yeah, no, I've had an interesting year, bit of a roller coaster from the end of ILCA, but taking forward a lot of the work we did at ILCA with Octopus on zero energy bills, developing that concept. And my role is now working with major house builders in scaling up that proposition. So we've announced a partnership with Bellway, and we're working with other major house builders and smaller builders. And we're also looking to see if we can take that approach into home retrofit as well. And where we're guaranteeing zero bills over time. So yeah, I've got a housing background and wrote this article a little bit out of frustration as to some of the activities I was seeing a year or two ago. Yeah, happy to dive into a bit of an overview of that and have a discussion around it, and yeah, welcome any comments and criticism. Go from there.
Yeah, cool. No, absolutely. So when I saw that post, I thought it was perfect for a Meshwork topic, for a Meshwork webinar. So let me stop sharing my screen, and then you can bring yours up. Nigel, let me.
Okay, can you see that?
Yeah.
Indeed, yes. Thank you.
Okay, great. So I'll do sort of 10 minutes or so sort of background and talking through some of the article, I guess the first point to say is I've been involved in delivering high-performing new builds and retrofits for some time, and certainly did advocate a fabric-first approach, and I still advocate the benefits of fabric. It's just perhaps not first. So I guess that was a point I wanted to make at the start.
Yeah.
I was involved in quite a lot of the early passive house schemes at Wimbish, Ditchingham, St Mary's. Built a lot of the early code for sustainable homes, level 6 homes to the original spec, which had a heat loss parameter of 0.8. Delivered some of the highest performing TSP retrofit for the futures, which had a keep it simple, good fabric and simple services approach. And I've done deep retrofits internally and externally to my own house as well. So this is not a anti-fabric message. This is a message around prioritisation and partly around cost effectiveness and carbon effectiveness. So one of the reasons I've moved this fabric fifth position is some of the key facts have changed. And in that sort of Keynesian way, when the facts change, I change my mind. What do you do? I think that really has provoked it. And from those early projects, when energy was relatively cheap in hindsight, we're now at the point where costs of energy are double what they were, and look to be staying at that sort of level in the foreseeable future. But what we're also seeing is with smart tariffs, the cost of energy can be up to 2 times less than what it was, so 4 times less than current prices, with things like the intelligent Octopus Go tariff at 7.5p a kilowatt hour. The carbon intensity of the grid's halved. The performance of heat pumps has improved significantly. But one of the key things that I've seen is the cost of insulation and the upfront carbon in insulation. The upfront costs have gone up significantly, so double material pricing. And I think the labour costs and doing a better job of insulation has put the costs up significantly, 2 or 3-fold overall. Well, at the same time, the cost of battery and solar has really plummeted. So even this year, the cost of solar PV panels has dropped 40%. Now, that might be partly oversupply in the marketplace, but the cost of solar is dramatically lower. But also the upfront carbon in a lot of the solar systems is also reduced. So a lot of the Chinese manufacturers are now generating their own energy that's feeding their factories rather than relying on imported or generated coal. So that changes the numbers quite a lot. And also, when you look at where things are going, a lot of those trends expect to continue, and they start to move to zero. So the grid already goes pretty low, and in Scotland it's been very low for a long time, but it will be starting to go to zero a lot of the time as we move to a full renewable system from 2025 at times, or full zero carbon system at times, with gas peaker plants coming on, which will mean the price of energy will vary significantly. It already varies a lot through the day, but we're expecting that to continue. We've started to see the integration of smart controls into cars, into battery systems, and now increasingly into heat pumps. And I expect that to become integrated as standard, ready to go out of the box to be able to smart control. And the costs of simpler, high volume manufacturable products has come down the cost curve, and we expect that to continue and also make it easier to install. Whereas insulation has a much harder route to reducing its costs and a much harder route to decarbonising its footprint. So glass, rock wool has got plans to decarbonise, but they're relying on significant government interventions or carbon capture and storage, which may take some time to scale. And the other thing we're seeing is as I've now moved into Octopus and really understood the energy market and the potential benefits and savings that can be unlocked through technology on homes that haven't got super deep fabric performance, that's really opened my eyes to and really question what I've seen happening. Is that the answer? So,
and then Nigel, did you? I mean, obviously you've been thinking about this for a while, but when you talk about when the facts change, you change your mind. Was this prior to the autumn statement? So obviously since then you've got the boiler companies are being incentivized to ensure that they provide heat pumps as well.
So I think the view around heat pumps being the most cost-effective route, well, being the route to decarbonisation has been pretty clear for some time.
Yeah.
I wrote in the City Journal back in 2016, sort of looking at the grid decarbonisation pathway, and that heat pumps were clearly going to be the answer, and gas CHP in particular wasn't a great idea. It's going to increase emissions rather than decrease emissions. So I think that's the role for heat pumps has been clear. I guess the question mark is, do you do the fabric first and then fit a heat pump? And do you need to go to a deep level of fabric retrofit in order to fit a heat pump? Certainly, the technology has moved on with heat pumps, and probably Simon can sort of talk to this as well around some of the experiences we're seeing, that it isn't necessarily, and customers don't necessarily want to do a deep retrofit to their house in order to get a heat pump. And if we're relying on deep retrofits to decarbonise our housing stock, we're not going to decarbonise fast enough. And that's partly why I think it's what we need to do, as well as potentially being the most economic and carbon literate way of getting to where we need to get to. Jump in and stop at any point if that makes sense. Otherwise, I'll crack on.
And Simon, sorry, Nigel. I mean, I presume you are in agreement with this premise, then?
Yeah, absolutely. And I think, as Nigel touched on at the start, the driver in the new build market, and to actually even in the social housing market, I think there's an argument there that with the eco funding that's available, with that level of funding and the procurement frameworks that are available, then we should be looking at wrapping the homes as well and doing as much as we can there. But certainly in the residential space, I think Andrew's numbers there, they speak for themselves. And I think where we're going to see this improve over the next few years is adding the labour cost line into those figures on the left of Andrew's slide there. When we see at the moment the labour costs associated to heat pump installations is incredibly high. We see the upgrade costs in a property are extremely high. And I think alongside the improvements in heat pump performance, we're also seeing improvements in the technology's capabilities, specifically operating at higher temperatures. So I think when you take all that into consideration with all those other factors, we'll definitely start to see a significant increase in heat pump installations. That may in turn have a knock-on impact in the short term in the seasonal coefficients of performance, but that can all be addressed over a longer period of time rather than trying to make all those upgrades to fabric and heat emitters all in at the same point of trying to fit a heat pump.
Cool.
So this was the article. I put it on just out of interest for those that perhaps haven't seen it. Fundamentally, I'm not saying don't do fabric, and certainly there are lots of homes that need significant fabric upgrades. I think, as I say, a lot of people have been thinking we've got to do deep fabric retrofits before we insulate, before we fit heat pumps. And I think in an ideal world, you'll do basic measures at the same time as a heat pump. But even that, we're starting to see customers at Octopus that are not going ahead with installs because of upgrade requirements to their home. That's one of the reasons we brought out a higher temperature heat pump, to enable people to decarbonise without needing to upgrade all the radiators in the home and upgrade all the pipe work.
Just jumping on that one as well, Nigel, because I think one of the factors that we're seeing a lot, and it's for those who haven't necessarily been on that journey, when somebody's going in and assessing the fabric of a property, we know at the moment that is done for the most part by eye. In a retrofit application, it's assuming what the U value levels of the walls and floors are. So we have this kind of overestimation when it comes to the heat loss calculations for the property, and therefore the level of upgrades that are actually required to make this thing work, because they have a direct impact on the size of the radiators that need to go into that home and the size of the pipe work that's needed to feed those radiators. So that we have this really kind of out of date assessment process at the front of the journey for the customer, where a supposed expert is coming in and providing this advice, and they're being told you're looking at, regardless of cost, they're being told you need to upgrade all these aspects of your property before you should even consider a heat pump. So the amount of consumers that are going through that area of the journey and then doing exactly as you said, deciding that they're not going to go ahead because of those factors, that could cause us a huge headache down the line, because those customers I believe they've had an assessment of the home and they've been told that it is not suitable for a heat pump. So it's very difficult to engage with that customer again and bring them back into the journey and say, actually, things have moved on. Let's have another assessment, because why should they believe the new person coming in saying, actually, you don't need to do these things, over the person that came in 6, 12, 18 months ago and told them that they actually needed to rip the whole house apart. So I think if we can start to engage with those customers on that improvement journey, rather than simply saying, you have to make all these improvements, or your house is simply not heat pump ready, then we may find that we're getting more consumers coming in at the front of the funnel and maybe making those improvements over time.
Mm-hmm.
So can I just ask a quick question there?
Yeah, of course.
Okay. On that point, is that also to do with the past 2035 training of assessors who come out, because they're told to look at the complete building and start with fabric and the smaller things first before you move to heat pumps? Having done that training, I found that there's a lot of people with no construction skills at all who do a 2-day course and then become those surveyors and assessors that come out on site. So I think if you're talking about, I quite like, Nigel's point of change your thinking. Don't just stick with what we would assume, but you've got to re-educate and retrain the people that are being trained up at the moment, because they're going through a sausage machine to say 2035. You look at everything, you start with insulation and everything else, and as you say, the market's moved on and evolved a bit. And my other question, a bit like Nigel, I'm looking at heat pumps and things, and I think one of the key issues is pipe work in the house. What size of pipe work do you actually need? Because it's not just the radiators. If you have half your house taken up with replacing all the pipe work, so it'd be useful to have some sort of guidance on that side. And the other thing is, can these heat pumps deliver enough heat into these older houses to actually keep them warm to the level that they need to be?
Well, I on your first point regarding the past 2035 aspect, that doesn't necessarily fall within the MCS, the microgeneration certification scheme approach. So the assessment there is purely based on the consumer or the homeowner having an interest in having a heat pump, and somebody going in and assessing the heat loss of that property. So it's so typically that could be a domestic energy assessor or somebody who has been on a heat pump design course. There isn't even a minimum technical competency for that person. So certainly in the building fabrics world. So that does generate its own issues. You do find that most heat pump installers are using a domestic energy assessor to do those assessments, but it's essentially going in and measuring each room in the property, assuming what the building fabrics are, and plumbing them into a calculation tool that has a lot of fat built into it to assess what the individual room by room heat loss is. So it's not so much that they're saying as past 2035 would say, you need to make these improvements. It's saying your home may or may not be suitable for a heat pump at this time. In order for it to be suitable, you need to potentially upgrade some areas of insulation, and in most cases upgrade significant parts of your heating system. Maybe to go to your final question then around the radiator and pipework upgrades, that all links. So if you've overestimated the heat loss of a room, then the amount of energy that you need to get into it means A, a larger radiator, but B, larger diameter pipework or higher flow temperatures. And I think we unfortunately as an industry, we kind of got to a position where we believe these calculations are correct. And we use them as our ultimate guide, whether that's from a compliance and regulatory perspective, otherwise. And what we're finding is that actually we are having an open and honest conversation with homeowners and saying, look, we know these calculations are inaccurate. We know that there's a lot of fat built into them. So let's design it at 65, the maximum we can do under MCS. let's upgrade any radiators that are absolutely mandatory at that flow temperature, and then let's see how the system performs. And if we find that over time we need to make further upgrades, then we can do. But certainly not walking away from the customer at that point and saying, if you don't do everything, then you can't touch it.
I think there's also a bit of a there's been a lot of negative press put out there around heat pumps and do they work in all houses? And a heat pump can heat any house or building. If you can, the challenges are the size of that heat pump, as Simon said, has said there, and sizing the emitters. And there is a balance and a trade-off to do around performance and disruption in the home, and that's one of the key things we're saying here. And it's interesting, around past 2035, pushing the sort of fabric first approach still, that there are, I mean, I was interested that the AECB, Association of Environmentally Conscious Building, have now got a level 1 retrofit, which is effectively getting a house suitable for a heat pump, which is what we're suggesting here. It hasn't got a minimum fabric standard, but it's suggesting doing basic fabric works, which is what I'm suggesting. Ideally, you do step 1, 2, and 3 together. You do basic fabric measures. You have a smart meter and smart controls, so you can unlock a smart tariff, and you'd fit the heat pump. And the reason I've got heat pump first is you don't have to do steps 2 and 3 to decarbonise your house. The key measure that unlocks decarbonisation is getting off fossil fuel heating. That's the key message.
Has Graham Hendra spoken to you about this, Nigel? Have you been in touch with him? Because picking up on Simon's point, I mean, or Tony, it's, you know, he does a lot of work, you know, even just, you know, on his son's house and stuff, where he's shown that you can get a heat pump in, and you don't have to change the radiators, you don't have to change the pipe work, yeah. And he's done all the maths and he's presenting it, and he does it in a very Graham way. It's almost like it needs to be the heat pumps are. I mean, it could be a bit Marmite, but I mean, ultimately, he's trying to uncomplicate the notion of being heat pump ready.
No, that's what I'm saying. We can fit heat pumps to home. If you've got a home that will be heated from a boiler, you've got a home that can be heated from a high temperature heat pump without changing. You might not get as good performance as you could do if it's running at a low temperature. And if you do then subsequently change the radiators when you're wanting to do the refurbishment or upgrades to the home to enable that to go at lower temperature, you get better performance down the road. So I think hopefully most people are in agreement that heat pumps are the answer to decarbonising housing. The question is in what order you do these work. Ideally, you would do fabric measures at the same time, so the basic ones. I think the more controversial point is putting solar and storage above major fabric works, which is steps 4 and 5 that I've got on my list. And I think the reason for that is that the embodied carbon calculations that I've seen and the financial payback calculations I've seen and run myself and seen from others do show that solar and storage financially and carbon pays back. Solar, certainly, the storage is probably a little bit more questionable, but has a big impact on the financial viability. But a lot of the deep fabric measures don't have a financial or carbon payback with high carbon materials. So glass, rock wool, petrochemical insulation products. And one of the things to deliver a carbon payback with fabric measures, you need to use lower embodied carbon materials, which are currently quite significantly more expensive than their higher carbon equivalents. So look, for me, there's a role for government through the funding schemes that they're doing to insulate homes, but start to bring in lower carbon materials into that to grow that supply chain, such that when we do deliver more and more insulation programs, we're not adding more carbon into the atmosphere in delivering better fabric performance. And that's something which I think we definitely do need to do more fabric. And we're not saying no fabric. It's currently there isn't a payback on most major deep fabric measures, so triple glazing, internal, external wall insulation, to achieve that from the numbers I've seen when you've got a heat pump providing the heating. And so that's where the numbers are there on a sort of typical house. And yeah, when you look at the running costs, the cost of electricity is 3-4 times currently the cost of gas, and hence why solar and storage systems providing electricity make a lot of significant financial benefits. and are much more cost effective and have a better payback than fabric measures. And that's just what we've seen and modelled and see in practice. And that's one of the things that I think people need to get their head around. And the other thing I think is hopefully useful perhaps to reflect on is the impact of what I call the third factor in performance. So massive focus historically has been on demand reduction. Big focus at the moment on how you get higher performing heat pumps through lower temperatures. But your running costs are determined, and your carbon emissions by partly in the tariff and the time at which you use your energy. And that is something which I think a lot of time people haven't focused much on, and that is something which we think needs a lot more attention. I think a lot of people think the cost of energy is fixed through the day, and the carbon intensity is the grid is fairly constant. This is a week's worth of energy last month, and you can see the price of energy is actually changes every half an hour, and people get an average price on their 27p a kilowatt hour, and at times it goes negative, and at times it goes very high. And the carbon intensity generally follows that similar profile. So when there is excess wind on the grid, the cost of energy goes low or even negative. And when there is a shortfall of wind and the high demand in the evening peaks, the price goes up. And so there's actually a pretty good correlation between price and carbon intensity of the grid. And therefore, by optimizing around price, you're actually optimizing on carbon intensity as well. So we think people understanding and thinking about the time at which energy is used can have a massive impact. And if you combine that with a heat pump or with a solar and storage system, you can move a lot of your loads to nighttime or afternoons in the summer when the grid is very low carbon or increasingly come to zero carbon and is increasingly lower cost. And that's where you can, the combination of solar, storage and heat pumps on a smart tariff has massive impacts on bills. And that's where we've got to is with the zero bills on the houses we're doing. And I think that's an interesting bit, which it was certainly, I was aware of this, but the impact this can have on bills is really phenomenal. And people getting their heads around the fact that energy isn't just a flat rate on as it is on gas, but electricity varies every half an hour. If you can move those loads, you can have a really big impact. And that's where a lot of the potential benefits can come from optimization. And one of the key things for us is how do we get that optimization into all homes and not just the able to pay tech evangelists that are probably on the early adopter list, probably not myself and Simon, around doing that work. And how do we roll that out as well so that people aren't left behind in that journey? I think that's a really interesting point to come to.
And I think it'll be a really interesting start when we start to see this kind of blended approach over the next few years, and it's starting to become normalized. Is what is that average pence per kilowatt hour for a customer that has that combined package of technology installed in the home that is utilizing these flexible energy periods? Because I think too often we see when a consumer is faced with a comparison against the boiler, we see this electricity is 3 times more expensive than gas. So your system needs to be at least 300% more efficient than a gas boiler. Whereas when we start to see this kind of data and the blended approach, we had Mick Wall on, who's Energy Stats UK, and I think he's paying somewhere in the region of about 10 pence per kilowatt hour of electric when he considers all the variables and everything else that he plays around with, and how he gets paid for discharging energy onto the grid, and when he charges his batteries using either low cost electricity or even free electricity. So
he chooses when he gives his stored energy back to the grid and gets paid accordingly.
There's certainly offerings from Octopus around that. You've also got things like the winter cashback scheme. So these things will become more normalized over the next years. But Mick himself maximizes that opportunity, albeit very very manually at the moment, but he's definitely in the adopter category. But when this does normalize, you know, this calculation that seems to be get flung around. I know Roger Bisbee was doing some post the other week where he did a very simple calculation on a whiteboard where he showed the cost of electricity and the pence per kilowatt hour of gas, and you know how a heat pump needs to be 350% more efficient for it to be saving you money. It's simply not the case when you have that combined system of solar, storage, and heat pumps. And you're on these innovative energy tariffs that are coming out of Octopus, the savings can be 20-30% against gas, and we're seeing that. We meter and monitor our installations, and we're seeing that even in 1930s semi-detached 2-3 bed houses based on the North Wales coast. You know, we're not talking about, you know, super efficient brand new homes. So you know, this is achievable. It's just not necessarily widespread at the moment.
I think one of the key things that I think is currently the case is a lot of the technologies you've got people who like Mick and others that are smart controlling the equipment themselves and setting up programs and APIs to link to tariffs, etc. What we're trying to do is simplify that. So in a zero bills house, the customer sets the thermostat time and temperature. We manage the battery, we manage the heat pump optimization, and we guarantee a zero bill. So it really simplifies the whole journey for the consumer. And it's the same with our intelligent Go electric vehicle tariff. You set the percentage charge you want in your car at a time, and you plug your car in, and the rest of it's done by itself.
Yeah, that's what consumers going to expect. I mean, yeah, there's not too many people like you and Simon around, so that is what's. And then when you talk about zero builds, is that only on new builds, or is that retro? Is that any house?
So to get to a zero energy bill, we need to generate typically more energy over a year than the house is expected to use, which does require a lot of solar, even on a new build home. So to get to a zero energy bill, currently we're looking at new build homes or recently built homes that can have a lot of solar on the roof to get to a zero bill.
Yeah.
In theory, you could do that to an existing home, but to get to a zero bill, you need to improve the fabric up to sort of new build standards.
Okay.
Which kind of potentially goes against my question. Do you need to do the fabric? And I would say we need to be improving the fabric on the worst homes for the people who are in poverty and cannot afford to keep warm from a health, social, society benefit, etc. perspective. And we need to decarbonize housing and not
it's two things.
Make it a barrier to decarbonizing housing to say you have to do deep retrofit, which has come out of some of the approaches that we've seen, and Tony's mentioned that is, if that's coming through past 2035 training, that needs to be considered. I think things like the ACB with a retrofit light heat pump first strategy is great to see, and hopefully that will start to others will see that.
Yeah, cool. Mike, did you want to come off mute because you've asked a couple of questions?
So I stop sharing and then we can.
Or did you want to put your 5 points up? You know, the one.
Oh yeah, put that back up. Yeah.
Yeah. So it's
keeps it.
Mike, are you still on the call?
Not that one.
Yeah, hi, good day, everybody. Yeah, this is very entertaining. So thanks a lot to the team. Question for Nigel. The first one is, does Octopus have real-time energy tariffs, dynamic tariffs for commercial buildings?
So I can't get the screen share to work now, but
yeah, don't worry, Nigel.
We are mostly focused on residential buildings. We do have a business energy arm. We've recently launched a smart, and we have smart tariffs generally for smaller businesses rather than massive industrial commercial. So the focus has been small business rather than massive industrial commercial. So there are smart tariffs available. There are tariffs which do load shifting. And we've also got an interesting tariff which we recently launched called Max Power, which directly links to renewable energy generation and incentivizes you to match your usage to the generation from actual wind and solar farms on a half-hourly basis, rather than currently a lot of renewable energy is done on an annual aggregated basis. So I've used 100 megawatt hours and I've bought 100 megawatt hours of renewable energy generation, but they don't time match. So to try and encourage people to match the timings of the solar and wind generation, that max power tariff has been pulled together, and we're doing that with some interesting companies to try and match the consumption with the generation that's coming from specific assets that they buy their power directly from, which is also quite interesting.
Great, thanks. Last question is for Simon and perhaps Nigel. Where's the balance between thermal storage and electrical storage? Electrical storage is pretty expensive. We're seeing some incredible work done in Scotland, for example, with phase change materials in the domestic hot water tanks, etc. You know, how do we balance thermal storage and electrical storage?
Yeah, it's something we've been doing quite a bit with, using SunAmp thermal batteries. Again, it plays into the rhetoric of the higher temperature heat pump systems that phase change material tends to operate better anywhere above kind of 60, 65. But we've actually been installing SunAmps into domestic properties alongside air source heat pumps now for about 18 months. It obviously makes a huge difference in terms of the space requirements for the property owner. So just from a convenience perspective, it works. Cost perspective, it also works. But it also gives us that opportunity to dump electricity off the network in periods of the day where the carbon intensity is low and the price per kilowatt hour is low. And then beyond that, we look at the thermal performance of the property as well, and seeing what we can do in terms of turning the home into a thermal battery. So starting to understand how the consumer uses that home in terms of the times of the day where they want it to be warm, but also monitoring the rate at which the properties lose energy. And that can be done now in very simple ways with external air temperature monitoring and internal temperature sensors. We can start to monitor the rate at which even individual rooms lose heat. So if we understand that a consumer wants a particular room or the whole house to be a certain temperature at a certain time of day, and we understand what the outdoor air temperature is going to be at that time, then we can start to, again, dump energy off the grid in times of the day where it's maybe more cost effective to do so, essentially overheat that home a little bit, but allow kind of thermal coasting to take it into the temperature that they need at the time of day when they want it. There's obviously limitations to that, and there's obviously an element of making sure that the consumer is comfortable in the home, but it's certainly got to play part of the overall mix.
Just to pick up on that, there's a research paper that's published by the Centre for Net Zero and Nesta, which covered the trial that Octopus supported last winter, and we've got another bigger trial this winter of heat flex. So turning up the heating effectively for 2 hours before an evening peak, and then turn the heating off for 2 hours, letting the house coast, and then seeing how customers reacted to that. And on average, on existing homes, the temperature only dropped 0.3 of a degree through that 2-hour window. So the house itself acted as a bit of a thermal battery, and that was in existing homes. Obviously, in new build homes, you've got better heat retention, and so that potential there is more significant. The other interesting finding from that was it was more, customers were more happy with an afternoon slight overheat than a nighttime slight overheat. So people didn't want the temperature of the house to get up to too high at sort of 4 in the morning, woke them up in the night. So that there is some interesting consumer behaviour learnings around when you can do load shifting, which was quite interesting from that study. The other thing on the sort of balance, I would say, in a typical existing home, moving onto a heat pump, you'll have about 3,000 kilowatt hours of heating, 1,000 of hot water, and 3,000 of electricity. On a new build, that's 1,000 of heating, 1,000 hot water, and 3,000 for general plug loads. So you can store hot water with for the 1,000 kilowatt hours of hot water quite easily in a cylinder or SunAmp. But for the heating, you can use a little bit with a thermal store of the house and the insulation. But for general plug loads, and some of the heating, having a chemical battery does make a massive difference to the economics. And that's why for zero bills we can't get there without having that chemical electrical storage solution. So thermal helps definitely, and the house is effectively a bit of a thermal battery itself, but chemical storage through batteries massively improves the economics.
What size of chemical battery are you typically fitting on the zero homes?
So on the zero bills homes, it's typically a 9 to 14 kilowatt hour battery. So not massive. The best way to describe it is suitcase sized, I think.
Yeah.
Battery, a single suitcase sized battery. Yeah.
It's interesting when you combine those two factors together, and I suppose as consumers move towards electric vehicles, then you're essentially having that as another bank of battery that's sitting externally to the property as well.
Yeah, no, the future with vehicle to grid, I think, is quite interesting, exciting. The technologies and the hardware is not there yet, but it's not far away.
Elle's made a point. I mean, she's obviously agreeing with a lot of what's said, and also sort of talking about the need for government support as well when it comes to bio-based materials. I mean, Nigel, are you aware of any large organisations lobbying the government to push and support bio-based materials? Because you spoke about that, and at the moment I'm presuming there isn't going to be much government support going forward for a while. So it's just educating the government, because like any of this at the moment, it's the more proactive developers and homeowners that are in a position to do this, and then hopefully those materials be used more and more, prices come down before we get support. But then I was also asking about what happens if we have another black swan event. So do we, in terms of still continuing to be reliant on energy as much as we are at the moment?
So on the bio-based stuff, ideally we'll have regulation on embodied carbon, and that will get some teeth actually start to bite. I think a lot of people are looking at it, but the economics are really hard, and they're going to stay hard until it scales. And it's a chicken egg, classic chicken egg scenario. And in my mind, it needs support on government funded programs to mandate a certain amount of, or financially support some sort of mechanism to introduce more fast growing bio-based materials. But because otherwise we are potentially increasing emissions through doing insulation programs, which doesn't feel right.
I mean, would they be able to adopt the same model as they're doing against the boiler companies? Not against is the wrong term, but obviously we're working with the boiler company. They're working with the boiler companies to incentivize them to supply air source heat pumps. It could be your concrete manufacturers.
I think it's a mechanism is in place for electric vehicles, even though the mandate's been pushed back for 2035. The electric vehicles have got a ramping up of percentage of sales, as have heat pump and boiler manufacturers now, and something like that could apply. Look, fundamentally at the moment there needs to be people having a go, understanding it, getting better data. At the moment, the level of knowledge in embodied carbon is really quite low, I think. There's definitely a lot. It needs to happen, and it needs to be pushed.
Alex and Tom have just said here that Kingspan now sell hemp insulation, and talking about how there needs to be consensus amongst insulation manufacturers.
Look, I think that's what it needs. It needs that level of being able to scale the manufacturing, but also I think the writing's on the wall a little bit in terms of this is the direction of travel we're going to have to go. It's a question of when we get there and how quickly we can scale it. It's similar to the whole gas boilers for heating versus heat pumps. We know where we've got to get to. I think it's a question of how quickly we can help scale these technologies up and roll them out and get this adoption. And that's fundamentally where the sort of Fabric Fifth approach came, was we need to scale up heat pumps as the priority for decarbonisation. But taking on the points as well, I think someone was commented around air quality and mould and ventilation. So in my step 3, I had sort of measuring and understanding air quality, looking at draft proofing where there's excess, drafts, but also making sure ventilation is understood. And that's a massive thing that I think past 2035 is helping people understand a bit more in that space. Yeah, it's comes back to the point around often there's problems even with gas heating, and that's moving to a heat pump isn't going to potentially fix it or potentially make it significantly worse. Potentially, if you can move to a smart controlled heat pump and do some basic measures, you hope to be able to have a lower bill and be able to heat your home to a higher temperature. So that would potentially help.
Cool. Okay. And Tony's asked a question around older homes. I'll just read it out, Tony. It says, with more traditional materials likely to provide more traditional materials likely to provide more thermal mass, so help with coasting. Also, how do we fit these thermal stores in properties that have limited space? Yeah.
Yeah, look, finding space for cylinders and batteries can be a challenge in particularly recently built new homes that haven't got much space. We are finding space, so we
in lofts. I mean, in the energy house in Salford, are they putting battery storage in the lofts?
There's options. You've got lofts, you've got cupboards, you've got outside as well. There are options. They are heavy, so you need to consider that.
Yeah.
They do kick out some heat, so ventilation again important. So there's a series of factors, but older homes, interestingly, they have got generally higher thermal mass, which means that they won't cool down as fast, but also won't heat up as fast. So there is a counter to that. So there's a combination of things there. So again, we're doing a bigger trial this winter around understanding that more with more homes, more house types, to try and really help understand how we can help optimize and flex thermal heating with heat pumps to truly inform ourselves and the industry through the partnership we do with Nesta around sharing that learning to see how that can be done.
We've been actually doing quite a lot of a lot more installations where the heat pump, the electrical battery, and the thermal battery have all been installed outside. Tend to find a lot of the battery storage systems. We tend to fit a lot of Give Energy kit, and their new all-in-one is IP65 rated.
Yeah.
We tend to fit that sitting above the heat pump, and then the thermal storage unit alongside it in a protected container. So, and the benefit with that is we can actually pre-plumb a lot of that work before it even gets out to the installation. So it's when we turn up on site, it's a lot more of a plug and play.
Because it's easier for maintenance as well if you sort of access it outside as opposed to crawling into loft spaces and tight cupboards and what have you.
I've never been a big fan of putting hot water systems in loft space. It can be done, but you also have to kind of reinforce the trusses to make sure that it can take the weight. And God forbid there was ever an issue, a leak, then it's the last place you want it to be if it's above the bedroom or what have you.
Yeah. Is there an issue with like grant access to grants for air source heat pumps on the condition that you have to make certain fabric changes?
So only the absolute basics that you would expect, and that, to be honest, should have been done a long time ago with the support that's been around for them. So minimum levels of loft and cavity wall insulation. But no, outside of that, because I think there was a point in one question somebody commented around the 65 degrees.
Yeah,
that was something that was certainly coming up in the early days of the boiler upgrade scheme grant. But the specific part of the regulations is that the system must be designed to a seasonal coefficient of performance above 2.8, and that it must provide heating and hot water. So that we're seeing now heat pump man, even the Samsung R290 unit, their HTQ, sorry, the Samsung R32 unit, the high temperature quiet unit, that was something like 3.2, 3.3 at 64 degrees. Then you've got manufacturers coming onto the market now. Obviously, Octopus are bringing out their high temperature unit, but you've also got the likes of certainly Panasonic, Viessmann, Valent, Daikin. They've all got high temperature systems now. And by high temperature, I mean capable of delivering 65 degrees and on the MCS register tested up to 65 degrees. So you can fit these systems into homes. This is what we're finding. We're putting them in, we're monitoring them. And even though we're designing them at 65, we've got systems now that have been in for over 18 months and they've never once gone above 55 degrees, even in the depths of winter. That's the fact we have in those calculations. So we're simply designing them at 65 to tick a box and to get through the accreditation process. But once they're in, practically, the systems are performing well. We have found that point that Nigel mentioned there about when we do the thermal coasting, we did make an adaptation to our system designs now, where we are zoning the bedrooms separately from the rest of the home, so that we can do that thermal coasting of an evening or overnight, on the towel rail circuit and the ground floor radiator circuit, simply because people didn't want that impact in the bedrooms. But yeah, they're going in, they're working well. And I think that's the crucial part, is we're actually seeing performance figures of seasonal coefficient of performance of 3.5 to 4. Now you can get higher than that, and I think somebody quoted on one of my posts the other day that they were getting 6 on their system. So it all comes down to A, the budget that the homeowner has, B, the level of inconvenience that they're willing to put up with, and C, how they want to control that system. If they want individual room by room zone control, if they want to be able to program it from their phone using a Nest or Hive, they're not going to get the same level of performance as they would have if they were allowing the system to operate using weather compensation, the manufacturer's controllers, with that adaptive element from an aggregation type service of Heatio or Octopus, is where we're balancing it on the grid.
Cool. No, thank you for that. I always come back to, the bad press that you read about is somewhat surprising when Scandinavia is leading the way and it's bloody freezing out there, and all the houses are heated by heat pumps, and we're still seeing the negative press. But that's a slightly different point to what we're talking about here in terms of fabric frith and everything. But it was good to see that the questions did relate to some of the, well, they're going to, but they related to the feedback that you got from your post on LinkedIn, Nigel. Obviously, air quality came up, and from a social housing perspective, we can't solve everything at once, but it's a very pragmatic approach to decarbonize homes, and it's still, for a layman, it's still all bound up with cost as well, Simon. We still keep talking about zero bills, low energy, getting our bills to be lower, but then ultimately it's about decarbonizing heating as well. We've got to 1 o'clock now, so thank you very much, guys. This is actually the last webinar of the year, so thanks for becoming, I think it might be speakers 53 and 54, but I've double counted you there, Nigel. So we've had a very good commitment from people over the last 12 months, so it's been fantastic. So I really appreciate, no one has to do this, it's you're not getting paid, but hopefully you enjoy it and we're spreading the word. So thanks to you, thanks to people who actually come on the call, and obviously we will post this, and more people should get to hear about you guys. So no, really appreciate it, and thanks a lot for everyone's efforts for today and previously.